Good evening, everyone. Today I'm going to discuss the question set matrix zeros from the Striver's SDE sheet with 180 questions. So the question is as follows: given an m into n integer matrix, if an element is zero, set its entire row and columns into zero. Basically, like if one of it is zero, so we'll mark it as zero. And the catch here is you need to do it in place. So we are given here input matrix and the output matrix. So like we are going to check the constraints. Here the constraints of m and n should be less than equal to 200. So for a solution, it should be like less than equal to 100. So the time complexity there is n raised to power 4, and if so the solution's time complexity should be less than n raised to the power 4, like n cube, around n cube. It should be n cube, n4 and n cube between. So and the follow-up they want is that they want a constant space solution over here. So the solution is as follows over here. Like, how can we do it? Like, logically, if you think, like we need to iterate both rows and columns and then mark it as zeros, and we need to do it in place. If you find in place now, so like the best idea here is to create a flag variable. So the key points like you can follow is like, first we have to like mark my matrix I. We need to search a matrix and mark I0 equals to 0, and if flag 1 equals to 2, and flag similarly we mark it as column wise, then flag equals to 2, and then we iterate both wise 1 to n, if and check if both are 0, then we'll also mark it as 0. If even one of them is 0, then also we'll mark the rows and columns accordingly. Then we'll iterate from and check if flag is equal to 2, then we'll mark them as 0. So the solution is as follows. Like, we are considering a matrix, so like we have created a 2D vector. So here int n determines the number of rows, and here int m is number of columns, and flag 1 is the boolean variable for this number of rows, and flag 2 is for columns. So we are going to iterate it. For int I equals to 0, we are performing iterating, and we are checking if we find 0. If we find 0, then flag equals to 0, and if we similarly, if we iterate all columns and check if we are finding 0, then we mark a flag 2 as true. Similarly, we iterate both row wise and column wise. So if matrix I comma j is 0, then matrix I comma 0 is this case, like if both matrix I and j are same, like here, so like we'll mark them as 0 and 0 and 0, like this case is this case. And similarly, we check for I equals to 1, then we again iterate both rows and column wise. If even one of them is 0, then we'll mark them as 0, like it's the case over here. Like if two different rows, like here it is 0 and here it is 0, so here it would be 0 0 and 0 0. We'll check in all directions. Similarly over here also, we'll check if flag 1 equals to 2. If matrix of I comma 0 is 0, then also we'll mark the flag as true. If flag 2 is true, then we'll iterate and mark the columns are 0 while iterating two columns. So the overall space complexity would be constant space O of 1. It would be O of 1 solution, space complexity solution, and the time complexity can be the time complexity. Here we are iterating n times, here we are iterating m times, here we are iterating n into m times because there are two loops over here, and similarly over here too it's n into m, and here it's into n and into n. Then we'll add all these solutions here, n plus m, n into m plus n into m, and here also n into m, n plus m. So the overall time complexity would be 2 into n plus m plus 2 into n into m, 2 into n into m. So it would be almost n into m, n square solution. We can ignore this, like something between n square and n cube solution. The time complexity would be that much.